Urine formation. See, urine formation. The process of urine formation involves three steps. The process of urine formation mainly involves three steps. Those are, first one is second one is and third one is secretion. Okay, so the process of urine formation mainly involves three steps. Those are glomerular filtration, reabsorption, and third one is secretion process. So first of all, let us see glomerular filtration. Glomerular filtration. Glomerular filtration. See here, glomerular filtration. See, the first step in urine formation is the filtration of blood. Filtration of blood, that is carried out by the glomerulus. Glomerulus. I will show you the form of diagram. This is glomerular. Okay, so the first step in urine formation is the filtration of the blood. The first step in urine formation is the filtration of the blood. Filtration of the blood. That is carried out by the glomerular. Therefore, it is called glomerular filtration. Glomerular filtration. That is the first point. Once again, the first step in the urine formation is the filtration of the blood. That filtration process takes place in the glomerular region. Therefore, it is called glomerular filtration. See, already yesterday and day before yesterday I said that the blood is received by the renal artery. The renal artery breaks into afferent arteriole. Through afferent arteriole, blood enters here. The blood is filtered. The blood is filtered. Filtrates. Here, the blood is filtered. The filtrates through Bowman's capsule entered into the renal tubules. Those filtrates are glucose, amino acids, next creatinine, urea, hormones, etc. These are all filtered here and passes downward direction, posterior direction. So through these proximal convoluted tubule, loop of Henle, distal convoluted tubule connecting that to renal pelvis, those waste materials are passed. So here some amount of useful materials are not filtered. So in the glomerular filtration, glucose, amino acids, creatinine, urea, hormones, such kind of materials are filtered and goes downward direction. Downward direction means renal tubules. But some of the particles are not filtered. Those are white blood cells, red blood cells, plasma proteins such as albumin, globulin, etc. These are not filtered. These are useful. Those useful materials through efferent arteriole goes to the body parts. Goes to the heart first. Okay, that's all. So this is the first statement of glomerular filtration. First point of the glomerular filtration. On an average, 1100 ml to 1200 ml of ml of blood is filtered by kidney. On an average, 1100 to 1200 ml of blood is filtered by the kidney per minute. On an average, 1100 to 1200 ml of blood is filtered by the kidney per minute. Okay, that's next year. The glomerular capillary, here this is the glomerular capillary. The glomerular capillary blood pressure causes filtration of the blood. See here, this is glomerular capillaries. The glomerular capillary blood pressure, this capillary blood pressure causes filtration of the blood through three ways. Glomerular capillary blood pressure, glomerular capillary blood pressure causes filtration of the blood through three ways. That is, first one is endothelium of glomerulus. Endothelium of the glomerulus. Here, endothelium of the glomerulus. There is one layer is present. Here, endothelium of the glomerulus. Epithelium of Bowman's capsule. Epithelium of the Bowman's capsule. This entire is Bowman's capsule. In this region, glomerulus. Here, endothelium is present. Epithelium here is present. The epithelium of the Bowman's capsule and basement membrane between these two. The basement membrane, this is called basement membrane between these two, play a major role in the filtration of the blood. Here what I say, glomerular capillary blood pressure. So these are glomerular capillaries. Glomerular capillary blood pressure, those capillaries causes some pressure. That is called blood pressure. That blood pressure causes filtration of the blood through three membranes, three layers. Those are endothelium of the glomerulus. Here is present endothelium of the glomerulus. Next, epithelium of the Bowman's capsule and basement membrane between these two layers play a major role in the filtration of the okay, that's all. Next here, next continuation point. This is, I said, epithelial cells. Epithelial cells of the Bowman's capsule. Epithelial cells. This entire Bowman's capsule. So the epithelial cells of the Bowman's capsule. See, epithelial cells. intricate manner. Intricate means mesh-like structure. Here, mesh-like structure. Podocytes, those are arranged in an intricate manner so as to leave small spaces. Intricate manner means what? Like this way. See. Okay, intricate manner means mesh-like structure. Deep filter how looks like that. Here arrangement. So those podocytes are arranged in an intricate manner so as to leave minute spaces. Like this way, minute spaces. Those minute spaces are called filtration slit or slit pores. Filtration slit or slit pores. Filtration, these are called filtration slit or slit pores. Filtration slit or slit pores. Okay, that's it. So this is the the epithelial cells are the Bowman's capsule. So this is Bowman's capsule. Here the epithelial cells of the Bowman's capsule called podocytes. These podocytes are arranged in an intricate manner, mesh-like structure. Intricate manner, mesh-like structure, or deep filter-like structure. So as these leaves minute spaces, like this, minute spaces behind the glomerular region. Those minute spaces are called filtration slit or slit pores. Through these pores, the blood is filtered so finely. Through these slit pores, blood is filtered so finely. Almost all the components of the plasma, except almost all the components of the plasma filtered, except white blood cells, red blood cells, albumin, globulin. These are useful material. These are goes back through efferent arteriole. Efferent arteriole is finally connected to renal vein. Veins, superior vena cava, inferior vena cava, we discussed that. So renal vein. So these veins, kidney region, these are present. So these are called renal vein. These veins carries those substances back to body parts through blood. Okay, that's it. See, almost all the components of the blood plasma except proteins. Those proteins, but the white blood cells, red blood cells, albumin, globulin are not filtered. Only unwanted materials such as glucose, amino acids, creatinine, urea, hormones, some ketone bodies, waste materials are filtered here. These filtrates from glomerulus and Bowman's capsule passes posteriorly to the renal tubules such as proximal convoluted tubule, loop of Henle, distal convoluted tubule, collecting duct, renal pelvis. Okay, in meanwhile, some amount of valuable glucose, amino acids, some amount of sodium ions, potassium ions, some valuable materials are involved in reabsorption process. reabsorption process. How much amount of glucose, amino acids, and sodium ions, potassium, some of the ions are filtered here. Those are all not eliminated through urine. From that, some amount of filtrates are reabsorbed in the renal tubules, such as proximal convoluted tubule, loop of Henle, distal convoluted tubule, collecting tubules. Finally, highly concentrated, less urine is expelled out in the form of urea. Our urine contains urea. Okay, along with urea, some amount of creatinine. So you may be asked, what is creatinine, sir? Yes, our body muscles, when our body muscles are involved in metabolic activities, at that time some waste materials are released. If we will eat more and more non-veg, some waste material is released. That is called creatinine. That creatinine frequently needed to be eliminated. If it is retained in our body, it is dangerous to the health of our body. Okay, ma? That's all. Okay, so this kind of filtration is called ultrafiltration. This kind of filtration, what kind of filtration? So almost all components of the blood plasma except proteins are filtered through 3 layers, through slit pores. That kind of a filtration is called ultrafiltration. That kind of filtration is called ultrafiltration. The amount of the filtrates formed by kidneys, the amount of the filtrates formed by the kidneys per minute is called glomerular filtration rate. The amount of the filtrate, see, here filtration happens. Unwanted materials or filtrates passes over. So this is the amount of the filtrates. Here filtration process happens. During that filtration, how much amount of the filtrates are formed by the kidneys, by both the kidneys per minute is called glomerular filtration with one mark definition. The amount of the filtrates, formed by the kidneys per minute is termed as glomerular filtration rate. Glomerular filtration rate in healthy individuals approximately 125 ml per minute. 125 ml per minute. That is 180 liters per day. Through glomerular filtration, the filtrate particles per day is 180 liters. In healthy individuals per minute, 125 ml of filtrates are formed per minute. This is if we calculate for one day, 180 liters per day. Okay, so this is glomerular filtration. Here one important point I wanted to discuss here, very important point. See, the kidneys have well-developed inbuilt mechanism. Our body kidneys have well-developed inbuilt mechanism, that is glomerular filtration regulation capacity. Our kidneys have regulate the glomerular filtration rate. It will not induces more and more, and it will not reduces. In optimal condition, glomerular filtration rate goes 24/7, 365 days. The kidneys have inbuilt mechanism, that is glomerular regulation of glomerular filtration rate. Such a beautiful mechanism is carried out by juxtamedullary apparatus. The regulation of glomerular filtration rate is carried out by juxtamedullary apparatus. Juxtamedullary apparatus will regulate the glomerular filtration rate. Juxtamedullary cells would not increases more and more filtration. It would not decreases the rate of filtration. Always maintains optimal condition, moderate conditions. That kind of a mechanism was inbuilt mechanism is present in our kidneys. Whenever glomerular filtration rate is decreased, immediately juxtamedullary cells activate and releases a kind of a protein that is called renin. Whenever glomerular filtration rate is decreased, immediately juxtamedullary cells activate and releases a protein that is called renin, which can stimulate the glomerular blood flow, which can stimulate the blood flow. It can increase the blood flow, stimulate the blood flow, glomerular blood flow. Thereby, the glomerular filtration rate can come to normal position. That condition then happens when here filtration rate is decreasing. The filtration rate should not decrease. Whenever, due to various reasons, when the glomerular filtration rate is decreased, at that moment, juxtamedullary cells immediately activates and produces a kind of a protein that is called renin. This renin stimulates the glomerular blood flow, thereby glomerular filtration rate brings to original position, normal position. In such a way, our kidneys always maintain glomerular filtration rate in optimal condition. It should not decrease, it should not fall, it should not rise. In optimal conditions, glomerular filtration rate is maintained by juxtamedullary apparatus. Okay? That's it. Next, here, someone asked doubts. Its continuation tomorrow we will see.